Right, let's begin. So, hello and welcome to Access Partnerships webinar, Pass the Chips, Opportunities for UK and US in Semiconductor Geopolitics. You'll see that we're joined by three excellent speakers representing different nodes of the semiconductor ecosystem around the globe, from design to manufacture. Semiconductors have rocketed up the agenda since the start of the COVID-19 pandemic, when their place at the center of the digital economy hit us like never before. Yet, much of the supply of leading-edge chips is concentrated in jurisdictions that are, let's say, in the midst of complicated geopolitics. Diversifying these supply chains raises pressing questions and diverse answers from leading jurisdictions. We're seeing companies announce tens, sometimes hundreds of billions of dollars in investment in new facilities, and countries seemingly in an arms race against each other to announce similarly sized incentives to reshape supply chains that have ossified over the last 20 years or so. As these multi-billion figures fly around, the next entrant to the world stage is the United Kingdom. We are still awaiting the UK Semiconductor Strategy with bated breath, promised as it is very, very soon, and promised as it was last week. So today we'll be asking, what are the opportunities for the UK in the semiconductor ecosystem now? How can partners like the UK, the US, and the EU work together more effectively? And talk about what are the fundamentals of success in this attempt to reshape global supply chains. My name is Mike Lawton. I'll be moderating your discussion today. Let me introduce my speakers very briefly, and they'll do so themselves later, and say a few words first about Access for Partnerships. So I'm joined by Joe Kinlan, who is the Director for EU Government Affairs at Seagate Technologies. See that he's been centered. I'm joined by Ricardo Mazuch of Intel and Stephen Patterson of ARM. A few words about Access Partnership before I pass over to our excellent speakers. Access Partnership is the world's preeminent technology-focused policy consultancy. We serve a range of technology. We exclusively exist to serve technology businesses and rapidly digitizing industries to achieve their goals in national, supranational, and international governance fora. We bring together economists, engineers, compliance and licensing professionals, and public policy professionals to make sure technologists and governments and regulators reach fair tech. I lead our UK practice as part of our Europe and US team, and we're supporting companies to navigate the emerging semiconductor strategies across the US, EU, UK, and other jurisdictions worldwide. As a bit of housekeeping, your questions are welcome in the chat at any time, but we will address those at the end. And if you want to get in touch with us after the webinar, please drop me a line. My email will be in our follow-up, and we'll circulate a recording. But first, let me pass to our panelists, starting with Jerry Kinlan. If each of you could take 2 minutes to introduce yourselves.
Okay. Hi, everyone. My name is Jerry Kinlan. I currently work for Seagate Technology. Seagate Technology is the largest disk drive company in the world. I've worked with them for 30 years, most of that time in operations and engineering, but for the last few years, I've taken over the role as Director of Government Relations in Europe. Now, I'm sure some of you are wondering what a data storage guy or a hard drive guy is doing talking at a CHIPS or a semiconductor forum. But it turns out that the technology, the skills, the equipment, the work processes we need to produce or write recording heads are very, very similar to those used in the semiconductor industry, especially synergistic with our colleagues in the compound semiconductor sector. We have 2 wafer fabs in the world, one in Minneapolis in Minnesota and one in Derry in Northern Ireland. In Derry, we have employed about 1,650 people in both manufacturing and R&D. We've over 100 PhDs on site. I think we've 28 different nationalities on site. When talking about compound semiconductors, photonics plays a critical role in our future technology roadmap. And in the last few years, we've led up a smart nano photonics cluster in Northern Ireland. To give you an idea of where we stand in the supply chain, the Derry plant, 90% of cloud storage is made up of hard drives, and 1 in 3 of those hard drives has a component made in Derry in Northern Ireland. So It gives you, we'll talk about supply chain resilience a lot. It gives you an idea where we fit in the global supply chain. Ted?
Thank you, Jerry. Can I ask Stephen to introduce himself next?
Thanks very much, Mike. I'm Stephen Patterson. I work for ARM, where I head up ARM's global public affairs. I guess everybody on this call knows about ARM. If you don't, we design IP and in particular microprocessors for the semiconductor industry. And we're best known, I suppose, for our position in the mobile market. But in ARM, one last point, we're a global company and our markets are global and a lot of our activities are done in places all over the world. But we started in the UK. The UK is our headquarters, and we remain committed to continuing to use the engineering excellence available to us in the UK to drive our business. So that means we're very interested in what the UK tends to do about its semiconductor strategy, and we very much look forward to helping the debate today and beyond in trying to put some flesh on it. Thanks very much.
And rounding out our panel, Ricardo.
Thanks a lot, Michael, and good afternoon, everyone. Thank you, Access Partnership, for this timely debate. I'm Ricardo Mazuch. I'm part of the Government Affairs team at Intel. I lead our work on the UCHIPS Act at the moment, but I'm also involved in a lot of government relations activities related to our plan to invest both in the US and in Europe. You know that over a year ago, a bit more than a year ago, our CEO, Pat Gelsinger, announced very ambitious plans to invest on both sides of the Atlantic to rebalance the global supply chain and somehow revert some of the trends that see now the US and Europe accounting for just 20% of the global manufacturing production, while just 30 years ago, Europe was accounting for 44% of manufacturing capacity and the United States for about 37%. So it's a very exciting time to work in the semiconductor sector, to work at Intel. Intel is one of the chip manufacturers that is able to produce the leading edge chips. We are an IDM, so just to put it in context, since everyone here described a bit where we fit in the supply chain, Intel is an integrated device manufacturer, which means that we design and manufacture chips, while there are other players that are designing their chips, and they are asking foundries to manufacture those chips, and then other players to assemble them. So it's a complex global ecosystem, and again, thrilled to be part of the discussion. And as others have said, I look forward to reading the UK strategy when published, and I hope we can contribute to the discussion and to move this strategy forward.
Well, thank you all again for joining. Let me start at a high level then. What does the UK even need chips for amid all the global activity currently announced? Let's start with you, Ricardo.
Okay, thank you. Thanks, Michael. Well, every country, right? Every national strategy should somehow reflect a combination of strengths, priorities, resource available. So I really look forward to see the UK strategy and how all these factors will play out. But from what I understand, that there's a strong focus on design, compound semiconductors, advanced packaging, because the UK has already some strong capabilities. There are already some industrial clusters in the UK that could probably better serve specific sectors that are more critical to the UK economy. I represent here a leading edge chip manufacturers. Now, the enormous attention to the semiconductor sector and the acknowledgement that semiconductor technologies are critical to our modern digital economy is going certainly to benefit all players across the supply chain. So boosting the semiconductor ecosystem in the UK will certainly benefit all players, because as we say, no, a rising tide lifts all boats. Now, I know that all the most advanced technologies, artificial intelligence, 5G, autonomous driving, cloud, will require a computing power that only leading edge chips can provide. And some studies show that the growth of consumption of leading edge chips in the next 10 years will be around 15%, while mature nodes will grow for about 3% of compound annual rate growth. So I think that it's a no-brainer for the UK as an advanced economy to develop capabilities on leading edge chips, because leading edge is what is somehow underpinning innovation across all sectors. And at the same time, developing leading edge chips requires more advanced technologies and more innovative skills for pathfinding and R&D. So developing capabilities in leading edge becomes a matter of technology leadership for a country like the UK. And I think that we're all in agreement, because I saw also the quantum strategy published last week, and it is clear that the UK wants to be at the forefront of technology and innovation. Now, it would be ideal to develop together with capabilities in R&D design, also some capacity in terms of manufacturing capacity for leading edge, because this may represent an enhancement of supply chain resilience for the country, as well as could bring, in my view, some additional trade and business opportunities. So let's see how things unfold. Certainly, Intel is looking at how things will develop in the UK and the future strategy, because I feel that the focus on advanced packaging, for instance, is extremely interesting. Intel offers a number of solutions in terms of 2D and 3D advanced packaging for heterogeneous integration. Advanced packaging is a very promising technology area, because it allows for increased performance, increased power, but also reduce cost and also reduce time to market, because leading edge chips nowadays are not just shrinking the dimension of transistors, but it's also creating a system where you can assemble together chiplets, dies that can provide the necessary power, the necessary capabilities in terms of memory, logic, with increased performance, and, as I said, reduced cost. So advanced packaging, our CEO says, will allow us to go from the around 100 billion transistors that are now today in a system to an era of 1 trillion transistors per system. So we are excited about the future, and we see that advanced packaging is among the priorities. So this is really encouraging. Thank you.
So for you, I hear the takeaways there are that the UK's place in the digital ecosystem and in advanced manufacturing relies on the presence of or capabilities in leading edge nodes. I saw Stephen nodding along at certain points of view. I'd like to invite Stephen to comment.
I thought Ricardo spoke very well about the issue, actually, and I very much look forward to the day when Intel they're building a fab in the UK, presumably pretty soon now.
I mean, that would be great breaking news for our webinar.
That would be great breaking news for our webinar, and great breaking news for a whole host of other reasons. And I'm not being sort of facetious. Of course, it would be great if the UK could, as it were, go the whole hog and do everything in this area. But I suspect the reality is that the UK government, in particular, will struggle to find the money to help create a leading edge fab in the UK. And that therefore the challenge that the government faces is, can it devise a strategy that doesn't have a leading edge fab at its centre, and does that strategy do what the government wants it to do? And you know, that question of what are you building this strategy for is actually quite an interesting one. Because you know, originally some of the concerns started with the mismatch between supply and demand for chips 18 months or so ago as we came out of the pandemic. And now there is much more capacity coming on stream in Europe and in the United States and in Japan to build more chips. So the capacity is going up. Then, but along with that concern about the supply chain tension, there was a growing concern about, are we all over dependent on high-end technology coming out of, in particular, Taiwan, but other bits of East Asia, that may turn out to be a troubled part of the world? And what do you do about that, right? So you can't, can you plausibly bring the whole ecosystem out of Taiwan and plant it somewhere else? Well, not in the short term, you can't do that. So if you're the UK, you've got to think, where can I put a little bit of money and resource and genuinely get some added value? And secondly, can I make sure that if the crunch came, I can still have access to the chips I really need in the UK in order for the country to survive? And, you know, really need in the UK in order for the country to survive. I mean, there must be a secret list in Whitehall of what they are, but they'll be the sort of chips that go into maintaining critical national infrastructure, probably some that go into health, probably some that go into defense. They may not be the sort of chips that actually come from leading edge fabs. So you need a kind of strategy which gives you some security of supply so that you can get hold of the chips you need for real strategic reasons. B, gives you access to new suppliers, whether they're in Europe or whether it's in the United States, so that you can make sure you can get cutting edge, let's call it ordinary chips, when you need them. And C, you need a strategy that identifies some key areas where there's a chance that the UK might be able to do enough to get a seat at the table when these things are discussed internationally in future. And that's the challenge, and we'll see how the government solves it.
So I see, Stephen, the key takeaways there for me are, you know, with all the money in the world, of course, we'd have leading edge manufacturing, I'm sure, in every town up and down the land. But you know, was that realistic? And how can the UK really add value with what will, you know, what looks to be a lot more limited budget than some of the other powers that have announced, or even some of the companies that have announced investments? Jerry, I'm keen to get your perspective here, because you're in this interesting position as a consumer and manufacturer in the semiconductor process, and you're underpinning one of the other critical parts of the digital economy, which is storage. So to come back to the original question, you know, what do you see the strategic need for chips for, and how would you comment on the other panelists' response?
Yeah, I think accurately, I'm making the case for the smaller player, Mike. But I found Ricardo's argument, you know, for building an advanced manufacturing base compelling. But I tend to agree where Stephen's coming from about what can the UK do now, what can it afford, and it needs a strategy that builds on its competencies. I think we have to remember that, along with energy, semiconductors is probably the world's greatest enabling industry. So it's not what's the semiconductor on its own, it's what enables, and Ricardo and Stephen both pointed out to that. You know, one of the things we've learned in this few years that we've been building the Smart Nano cluster in Northern Ireland is the relationship between life sciences, again, the other industry mentioned in last week's budget, and photonics. So I find myself agreeing with Stephen that we have to look at what we're what we have and build on that base, build on it to an extent that I think we have sort of tradable capabilities or tradable competencies. In other words, that we are leading in certain areas. So obviously, for, at this point, I have to champion, and I think that has to spread across the entire value chain. If we're going to compete, whatever clusters we pick, we have to. We need development, we need manufacturing, we need integration, and we need packaging. We need everything across within whatever clusters. And I actually think that the compound semiconductor footprint is big enough to build on, especially if you add photonics in as a complement to what already exists. And by engaging a compound, yes, I acknowledge the many advantages of semiconductors, but in compound has advantages in power, speed, light, and you look at areas of particular interest. Well, obviously photonics and healthcare, whether it's detectable diseases, wearable devices, or whatever, there's a connection there. But if you look at, say, electric vehicles, for example, more than half the semiconductors needed in that industry are compound because of the need for power electronics. So I definitely feel that I find myself in many ways agreeing with both speakers. I agree that with Ricardo, there's a place we should get to when the time is ready. But I also find myself agreeing with Stephen that the path starts with where we're at today, and we have competencies in design, obviously, and we have competencies in emerging technologies, and we have evidence, a lot of good clusteral evidence in semiconductors. So that's my take on it. Is sort of in between the two. It's great to have the vision of where we might get to, but that has to be based on where we're at. And I do think, right, that the strongest manufacturing competency or cluster competency we have is around compound semiconductors, aligned with what we're trying to do with photonics in Northern Ireland.
I'm taking with the phrase that you've put in your answer there, Jerry, around tradable capabilities. So I think what I'm hearing from your answer is that the UK can still, maybe slightly against Ricardo's answer, that the UK can still find leading edge cluster, leading edge industry in, I think you mentioned life sciences and electric vehicles, without the very leading edge nodes, and there's still a great deal of transformation possible through photonics on sort of in other sort of forms of chips that are not, in the ever decreasing nanometer race. And it's really interesting.
Eric Patterson can come up with a phrase that he doesn't really know where he got it from, but yeah, I think that's right. Yeah, I mean, I do think it's important to keep an eye on where we ultimately have to get to. But the important thing in the next 5-10 years, I would also add that, semiconductors are the eye of the storm, the geopolitical storm, and that storm is going to rise and ebb over the next number of years. But we don't know where it's going to fall. And if you do take on, if you don't take on as broad a challenge as you can, or if you take on one that's fraught with that overcommits yourself, you're putting yourself at the edge of that. You're right in the middle of that storm. And I think that the safest and best way for the UK to do it is to not overcommit, but at the same time tackle the industry in as broad a way as is feasible, both technologically feasible and economically feasible.
Stephen, I think you want to come in there.
I was going to come in. I think there's a really interesting point here that we haven't actually distilled from the conversation so far, which is, how can I put it? I think we would all agree that in order to succeed, you do need to have an ecosystem. It's not just a question of setting up, one company, however good they are and however successful they are, but you need an ecosystem. In a sense, the fact that the UK has such a strong design sector shows that actually with one or two companies, you get others coming, you get startups coming, you get universities interested in it, you begin to create an ecosystem. And I think that's key to the strategy. And I think that's the really good point about Ricardo's vision, because I mean there is a sense in which you need to identify something big you want to do, and then you will discover that all sorts of other people come and cluster around it. And so that's the advantage of having, a leading edge fab, in that it kind of brings other companies into the UK to work with it. And but we will have to, if we're not going to have a leading edge fab, we'll have to see if we can replicate that by finding other areas where similar sort of effect might be achieved. And that might be, I mean, I mentioned design, semiconductor design, that's one, but that's already, dare I say it, pretty strong in the UK. I mean, considering compound, which Jerry mentioned, advanced packaging, which Ricardo mentioned. I mean, all these are areas where, you might call them niche, but actually they're extremely significant for the future of semiconductor technology, and they're opportunities for the UK to plant a seed that will grow into an ecosystem. And that's what I think the government should be looking for.
Well, I was going to summarize your comments as niche, but Stephen, you've rightly told us that niche might be the wrong word there, and I've suddenly found myself lost for another one.
Well, I mean, it's Jerry's point, really. I mean, you never quite know where this sector's going to go, right? I mean, so, if how can I put it? If the UK were to become the Taiwan of advanced packaging, I don't think we would call that niche anymore. We would call that as this is a serious enhancement of the technology.
The Taiwan of advanced packaging. I think that might be the quote for the press for DSIT when we hear from it. Maybe. I think we're sort of already getting into this discussion, but let me put a little bit more direction to it. How can the multiplicity of national strategies be complementary rather than competitive? We've talked about the US CHIPS Act provides some hundreds of billions, Samsung's announced hundreds of billions, the EU's announcing tens of billions, and member states were in more in terms of generous state subsidy regime adjustments. How can we avoid a situation where effectively these powers are competing for the same limited sets of skills, sets of resources and investment, and crowding each other out? And when we come to the aggregate, we find that we've not quite managed to truly establish an alternative to Taiwan. And let me start with Stephen on this one.
I think it's a very important question, because how can I put it? One of the things we're seeing that's that's concurrent with this debate about the semiconductor supply chain is what a lot of people are describing as the end of globalization. I mean, for all sorts of reasons, people are now saying globalization looks like it exposed us to too many supply chain risks. Let me put it no higher than that. There are other issues people have with globalization, I know. The plain fact is, though, that the semiconductor sector is one of the most intensely globalized sectors there is. I mean, I've forgotten the figures now on how often a border is crossed in the construction of a single semiconductor, but it's an awful lot for something that small when you take into account the raw materials and so on and so forth. I think it's important that as we go forward and try to improve, if you like, our resilience in the event of shocks, geopolitical shocks in East Asia, that we don't lose sight of the importance of globalization, if you like, in the rest of the world. So that, again, if I were a British official, I'd be looking at stronger partnerships with the EU over access to chips once their plant is built, with the United States over access to their chips, with Japan. I've been looking at ways in which we can actually begin to strengthen globalization in some of these areas first. And that, I think, would help avoid a kind of panic effort, but with everybody trying to do their own thing and it crowding out investment. And I mean, to be honest, the strategies built against those backgrounds never turn out to be terribly efficient.
Ricardo, I see you nodding, so maybe you'd like to add.
Well, Stephen already put it beautifully. Couldn't agree more. It is true that during the last couple of years, 2-3 years, this globalization crisis in the semiconductor sector became even more apparent, because almost everyone acknowledged the fact that the supply chains that were designed to be able to supply, to deliver just-in-time products and leverage, in a cost-effective way, the different suppliers, partners around the world, could not cope with unpredictable, unforeseen events, disruptions, choke points, etc. And so now we need to transition from this supply chains that are just in time to supply chains that are somehow able to bounce back and be more resilient, and just in case there's a disruption, they will be able anyway to deliver products. So this shift, paradigm shift from just in time to just in case, it's particularly significant. However, this doesn't mean that we need to reshore the entire supply chain in one region. It's totally unrealistic because our sector is very capital intensive. The technology is extremely complex. There is a very strong specialization and concentration of technologies and niche, to use a word that we were referring earlier. So it's unrealistic that we are going to turn global supply chains into just regional supply chains. But this is the challenge and the opportunity that we have in trying to boost and strengthen local ecosystems while maintaining our semiconductor supply chain global and still continue leveraging excellencies around the world. Now, the interdependence among regions should not be seen as a disadvantage, but rather as an opportunity for increased collaboration. And I'm looking at collaborations in terms of R&D, of exchange of talent, because probably we haven't touched upon this point, but this is also a key ingredient of any semiconductor strategy. And so, as also Stephen was hinting at, UK should think of stronger partnerships with like-minded countries, starting from the US and the EU, because the US and the EU are facing similar challenges, and they might, and we all together might find common solutions to these challenges.
I think you touch on, both of you have touched there on the international dialogues that have taken place. And just before turning to Jerry, perhaps I'd just like to ask you all: are the dialogues enough that are happening? We know there's the EU-US Trade Technology Council that is very much discussing kind of early warning mechanism on semiconductor supplies. The Eurasian UK-US digital partnership discussion as well, and there's discussions around that. But are these enough? Are these mature structures, or do we still run this risk of, as soon as something turns south, we get back into panic mode? Stephen.
I don't think they are enough. I mean, and these things are never enough, right? I mean, how's that old saying from the military? No plan ever survived the first encounter with reality, or whatever. And I mean, and there is an example. For example, in the UK's relations with the EU, the UK companies are still not being supported by the European Commission to take part in Horizon research programs, and that's the kind of cooperation that I think we need more of. And you need it with EU companies, and we need it with US companies, and we need it with Japanese companies. And I think we need government to government contacts and partnerships that facilitate those kinds of things at company level.
So not enough by a little bit of a distance there, Stephen, I see. And politics still getting in the way of strategy, maybe, if I could put a spin on what you said. Jerry, I'm keen to open the floor for you.
Yeah, Mike, I mean, I find myself agreeing with both Ricardo and Stephen. Obviously, there's not near enough international cooperation of like-minded countries. However, I do think there's opportunity for the UK here. I think the focus in the US, what I've witnessed about the US Chips Act to date, and similar language in the EU, I think there'll be a focus on just the trade figures, the amount of manufacture and market that's reshored. I think the same thing will happen in Europe. There'll be, of course, there'll be focus on national defence, right? But as discussed already, right, there's a huge middle in between the leading edge and sort of very old legacy stuff. And I think that if the UK, pick the right targets, builds clusters in those areas, and gets the communication going within that cluster. So whether it's photonics or something, obviously I'll pitch our own area, but there's a window of opportunity for a few years, right, to grow that particular sector, to grow international cooperation, because I think all the high level geopolitical attention will go to the trade figures, market share, will go to national defense, and there's a window there for a very smart nation to really work within niche areas. I won't let's call them scalable. Let's take the word niche out of it, or let's call it, I forget what you call them. But I think there's a huge window there for us if we're intelligent, if we're bright, and to really start building the collaboration in those areas. But that's a science all in itself. Of course, in Northern Ireland, we have an added advantage in that hopefully we've access to both markets now, so we have to figure out how to make the most of that. Right, so it's the one time in history that politics doesn't get in Northern Ireland's not getting in the way. So
I mean, we'll see how the vote goes tomorrow, Jerry. But
yeah,
don't speak too soon.
Yeah.
But yeah, actually, it's a fair goal, I think, to point out that Northern Ireland does have this quite advantaged place, and maybe would be a good model for the rest of the UK, really, to try and foster some of those dialogues. But on that, it's a whole different webinar.
Yeah.
I hear through the last two questions there have been other ingredients, and I appreciate we're sort of over the halfway mark, and we've got some fantastic questions in from participants. So please do keep sending them in. We'll try and address as many as we can. But what else will it take to make these strategies successful? What are the common challenges around interdependence and skills and capital that really need to make these things work? I appreciate go back to Steve's point. You can't just sort of plonk a wafer fab in the middle of the Atlantic Ocean and expect it to work. So maybe I'll open with Ricardo.
Oh, thank you. Well, we mentioned earlier the importance of resources and financial resources. So it is undeniable that if the UK wants to pursue a successful strategy, we'll probably need also to back it with substantial resources, or at least it is important to acknowledge that in the past successful jurisdictions that somehow offered grants, tax credits, and in general government incentives to attract investments, well, this played a phenomenal role in the growth of Southeast Asia, right, in the semiconductor sector. So this element is undeniable. However, this is probably not the only element, right? And there are other things that money, that not only money can fix. We refer to, I briefly refer to skills and skills creation, and again in the perspective of a long-term ecosystem that everyone here pointed at as really a sort of long-term objective that every country should have. Well, creating a strong talent pipeline is certainly a priority, and the UK has already a worldwide renowned academic and R&D system that can leverage and to be able to educate the next generation engineers that will be able to develop the next generation semiconductors. And probably another element before I pause is the importance of creating an attractive regulatory environment. And a good example is fast track procedures for permitting for new manufacturing facilities. This is something that is quite explicit, for instance, in the UCHIPS Act, because if the government acknowledges the fact that investments in semiconductors are strategic for the economy, then there should be a way for speeding up some of these investments. So skills creation, fast track procedures, and in general a more favorable regulatory environment on top of international cooperation that we already mentioned.
I think here at Access Partnership we often get we abstract away from land and things like that. So it's important to know that the semiconductor strategy often hinges on making sure the local parish council doesn't object to the buildings, and it's instructive. So much of the infrastructure hinges on things like these. Stephen, Jerry, would you add anything? There, I think Jerry, particularly, I'm interested in you've mentioned several clusters like electric vehicles and life sciences. I'm interested to see particularly your view on the skills pipeline there.
Well, I think I'm always drawn to when people talk about what's needed. The UKRI strategy is built on 4 principles, and I think we need to keep them. I think they're excellent. Inclusivity, diversity, connectivity, and engagement. Right. So I mentioned earlier we have 28 nationalities on site here. We have to be able to attract these skills from anywhere in the world. Right. So, whatever regulatory, whatever salary caps or whatever we have to do to attract them, not just to industry, but to academia as well. We have to do it. Again, we have to connect broader internationally, but I think we also have to connect nationally as well. So the more councils, the more institutions that connect us, because there's a lot of complementarity between sort of what we all do. It may seem discrete and we may appear to be separate, but there's a lot of complementarity between silicon and photonics, even though photonics is compound based at the moment. So I think the more institutions that build, that connect us, that allow us to engage both internally and externally is important. Diversity is really important. Fabs are a very expensive thing, and we heard already they can go from hundreds of millions to tens of billions. But I think the idea of an open access fab, or an open access facility where possible, it brings more people in, it brings more potential to bring more academics in, more SMEs in, and I think that's an area that we should be mindful of. The idea of increasing access to what is a fairly prohibitive space at the moment.
So adding to skills and fast tracking permits, I also hear a call for creativity and looking for things like open access facilities.
Yeah.
Stephen,
what I always say in this, when the discussion gets to this point, is to make the following observation, which comes out of what people have said about development studies, that everybody knows the ingredients, but no one knows the recipe. So we can all list half a dozen things that a successful, thriving digital sector would have. But when you say, well, where do we start, and how much of this do we need, and when do we add that? It's not so straightforward. And so, it's a puzzle, I think, and it's a great puzzle for policymakers. I think, it's my personal view, I think the universities are a good place to start. I think we need, so if I was to be doing this government strategy, and I was to think, for example, compound is an important area I want to look at. the integration of compound with others, heterogeneous computing is going to be on the agenda in whatever it's going to be, 5 or 6 years' time. I might be trying to incentivize the universities to start to do some work in this area, working with companies and seeing if the universities can build expertise and so on. And the second thing I do in universities is that I'd look at combining computer engineering courses with business studies courses, because I think, you know, it's a bit of a paradox. So, yes, some of the world's great companies have been made by engineers, but actually quite a lot of them have been made by engineers in cooperation with really good business people, entrepreneurs. And that, I think, is something which the universities could work on, and that might sort of help kickstart some new innovation in the UK.
I see Ricardo's looking to come in, I think.
It's a great point what Stephen just made. To be able to educate and inform the men and women that will develop the technologies of the future, we really need to start from universities and the education system more broadly, not just the higher level education, because we need also a lot of technicians in fabs, and it can be also at a high school level. So government, business, and academia working closely to craft also some curricula that could really lead to the skills that are needed in the future is a great challenge and the greatest opportunity. Really, the basis, the starting point to build a thriving semiconductor ecosystem.
So I think we've definitely given more homework to the policymakers there. But Jerry, I think you're coming in again.
Yeah, universities undoubtedly play a critical role. But I'm not so sure that university-led is the right model. Maybe, you know, our experience in Northern Ireland is an industry-led cluster, which, you know, is unique to Northern Ireland, but I think we've built good momentum around that. So I don't, you know, there may be different cases, but I think there are times there are certainly times, sectors maybe where industry-led might be more appropriate than university-led, but definitely agree that the university, the curricula, and I love the idea of sort of mixing compute with businesses. It's really critical. Yeah.
And let me say, I entirely agree with Jerry's point and Ricardo's point that you know, what you don't need is a lot of people who go to Oxford and Cambridge and come out with computer science degrees. You might need some of those. Yeah. But, you know, if you look at the kind of the guys who made the Industrial Revolution in the UK, they weren't, as it were, top-notch kind of people of that sort. They were people who knew their industry, knew their sector. So, you know, we're looking now at people coming up through apprenticeships and trying to get those people who understand the technology from the inside, looking at how they can innovate from within. And I think we need to think about building the skill set much more widely than just trying to get more and more people into a smaller number of elite universities.
I thought we couldn't make the calls more ambitious except for a new industrial revolution led by apprentices, Stephen. So I think that's a fantastic takeaway here for everybody. And maybe at this point, I'd like to just open a few questions to the floor. They've been flooding in. I think maybe we've just got time for one or two. I think firstly, we've made this assumption in this panel that the West, or the West and its allies, can reshape the supply chain. But we've had a question here that asks, in which areas of the Western supply chain could the competition of China effectively disrupt those strategies? The panel have any thoughts on this?
Sorry, in which areas?
In which areas of these efforts could the competition of China sort of effectively disrupt? In what way could things be lured back? I think is where the question's coming from. If the person is still in the panel and wants to ask the question.
The thing about that, the reason why everything went to China is obviously because, labor costs were lower there, right? Skilled labor costs were lower in China. I mean, there are other reasons as well, but basically skilled labor costs. And that was at a time when labor costs were a significant part of the overall costs of any manufacturing operation. That era is changing. We can now look to a time where actually quite a lot of manufacturing, not just in semiconductors, is done robotically, is done by automation. So the labor costs are a less important part. But what is now an important cost are the energy costs. And that is where, we need to make sure that if we're gonna try to develop alternative sources of manufacturing and supply outside East Asia, we need to make sure that they don't become so expensive because energy costs are so expensive. And that is a real conundrum. So, I mean, I know, Michael, you complained that Industrial Revolution launched by Apprentices was too ambitious. Now we're trying to solve the world's energy crisis, which is, I think I better ring off, otherwise you'll have too many more things to do.
I think it's fantastic. We've got big interconnected challenges. I saw Jerry and Ricardo nod along at different parts. Anything you'd like to add?
Oh, couldn't have said it better.
Agree.
Lovely outbreak. Okay, so great outbreak of consensus there, and I hope that answers the question.
Advanced packaging is a good example where assembly and test traditionally has been more labor intensive compared to front end manufacturing. Now advanced packaging, also because of automation and the tech complexity, requires probably more. It is probably more capital intensive than the traditional packaging, and so this can be a game changer also to reshore some of these activities in jurisdictions that are that are less competitive from a labor perspective. The point on energy prices is invaluable at the moment, because it's the one of the biggest operational costs that make regions like Europe less appealing for investments.
Yeah, Mike, if I could add there, at one point last year, we were sister plant in the US. Our energy costs had increased by a couple of 100%. In the same period, it was only 20% in the US. So there's a lot of compensation. Now, it was for a window, but there's a lot of compensation to be done there to compensate for that. Okay.
So sorry, just to make that clear, the plant in the UK
The plant in the UK, yeah.
multi-fold increases in energy costs. I see. So that's going to be a huge point of vulnerability, I think, for the UK strategy going forward, I guess. We've just got 5 minutes left, so maybe I'll turn, as all good panels do, to the future, and just ask panelists, where would you like to see the UK's or the West's ecosystem in 10 years if the strategy has been successful? And or pick a more suitable time horizon given the length of change, but I'll ask Jerry first.
Cool. A couple of things. One is that UK policymakers recognise that semiconductor and design and manufacturing are key drivers, just not of national security, but actually economic security as well. That's really understood by all policymakers, and from that will flow progress. I would say that in both compound semiconductor, I mean selfish here, right, and in photonics, right, that the UK is regarded as the most productive and creative cluster in the world, and then that people understand the societal impact of some of these new technologies. So I mentioned earlier in terms of photonics, in terms of blood pressure and cancer detection, what we're talking about here is technologies in an industry that can improve people's lives. And I'd love in 10 years' time if in the UK ever really understood that.
So, semiconductors to save lives.
Yeah.
I think, yeah, I like that. It's a bold measure of success again. Ricardo.
Probably also to summarize our discussion today, it would be fantastic. It would be really great if the ambition was to become a truly international player with very distinctive areas of excellence, and not niches, but very distinctive areas of excellence across the entire supply chain. a country that can be in regular dialogue with like-minded countries around the world, and that can be also, the place that where the best talents can grow and somehow steer the direction of future technology.
And Stephen,
I agree with both those. I think, yeah, it would be great if we had a UK tech sector that people associated with the UK as they associate the financial sector with the UK right now. So instead of just thinking the UK's a one-trick country with financial sector, they'll be thinking financial sector and something to do with digital semiconductor design. Yeah.
I think that's a really good note to bring our discussion towards its end with just 2 minutes to go. So I'd just like to take a second to thank all of our panelists for joining. I think we've raised more questions for the forthcoming UK strategy, so I'm sure they'll be very pleased to hear about our write-up. And the panel, and again, to thank our participants for a very lively discussion in the chat. I'm very sorry that we were not able to address all the questions, but we'd love to follow up with you and have some further discussions. Thank you all for joining, and we'll leave it there.
Thank you.
Thank you very much.
Bye, everybody.
Yeah.